Welcome to the 2019 REBNY PropTech Challenge finalist presentations in partnership with the MIPIM Startup Competition. This year's Architecture, Engineering, Construction, and Development category was sponsored by Silverstein Properties and AEC Tishman. Next finalist is Christopher Mitchell from Geopipe.
Hi there. Have you ever considered what it would take to create a perfect copy of New York, San Francisco, or Paris that you could explore in your computer? Hi, I'm Dr. Christopher Mitchell, and I'm excited to introduce you to Geopipe. Creating virtual models of the real world is a core problem across many industries where visualization, simulation, and interaction are vital. Today, sensor data like photographs and laser scans are increasingly inexpensive, but AEC professionals don't just need raw data. They need 3D maps and 3D models. Today, they spend thousands and thousands of dollars and weeks or months hand-building these models. Geopipe is the missing link between data collection and data presentation. Specifically, we use AI to turn raw sensor data about the world into rich, labeled 3D maps and immersive 3D models. In fact, we know what's in the world, not just how it looks. Our models are more flexible than Google Earth's photogrammetry, and you can actually pull them out and use them in your own visualization and editing software. Unlike Esri City Engine and Mapbox, we don't rely on human-labeled OpenStreetMap data. Instead, we start with raw photographs, laser scans, and other data. We process them through a machine learning pipeline that understands where every building, tree, road, sidewalk, window, and material is on a city scale. And we can build an entire model of something the size of New York in just a day. Our Geopipe Context Snap product lets AEC professionals explore our city models within a web browser, including clicking on any building to see everything we know about it. You can then select an area of interest and immediately download a 3D model that you can use to visualize a new building in context, or even create beautiful visualizations. You can download a model at any level of detail and file format that you need for your own software. If you're creating a VR experience or an interactive visualization, we allow you to take Geopipe's SDK and load models directly into programs like Unity. Geopipe is working within a $17 billion market of 3D mapping and modeling, within which $8 billion will be spent next year on the types of 3D modeling that Geopipe accelerates. We charge a monthly or annual license fee for most AEC use cases. If you want to pull our models into your own software, we charge a royalty. And we have bootstrapped Geopipe with $1.5 million in funding, including $1 million in non-dilutive funding and stints in Techstars New York City. We have 2 fully functioning revenue-generating products, and we're now expanding our team and raising our funds. I'm Geopipe's CEO, Dr. Christopher Mitchell. My co-founder, Thomas, and I have worked together for 15 years, have PhDs in computer science, and have exactly the skills necessary to solve this problem. If you're as excited as we are about the promise of being able to turn cities into immersive digital twins in days, we would love to speak to you. We are Geopipe.
Christopher, a couple questions.
Sure.
How many cities do you currently have geopiped? That's a new word.
Absolutely.
And how you said in a day,
Correct.
but how do you do that if the photographs like Google Earth or we are not being constantly updated? Like, could I see a building being built on a monthly basis, and how do you update that if nothing's being shown on Google Earth or any other public sort of realm?
Absolutely. So we currently have 6 cities that we model, covering about 4,000 square kilometers. We have spent most of our development focusing on rapidly increasing the level of detail we can reproduce about the world rather than broadly expanding to cities. We generally add a new city when a customer needs it. So we work from a mix of public and private data, so public data from federal and state governments, from open sources, but increasingly we've been working with private companies that will, for a fee, go out and collect photographs, laser scans, and other types of data. So because we can pull in different types of data, our system can figure out when a new building has gone up if it's only pictured in one type of data, not in another. We generally aim to update our models about every month now by getting that new data and pulling it in. Because our system is fully automated, it can update just the parts of the world that are new since the last piece of data.
What's the competitive landscape for this? When you see Facebook and Google getting into the space, are you guys kind of first movers here, or what's it look like right now?
We're first movers in terms of being able to apply machine intelligence to this problem. Almost every solution today produces essentially 3D pictures with no intelligence about what's there. But if you have a tree that's just a weird green blob and a window that's just a photograph of a window glued on the side of a building, you can't use that for beautiful looking visualizations where the sunset reflects off a window, and you can't open that door and go into that building. We have, as I mentioned, the unique skill to do this. We have 3 years of experience building the algorithms that can do this, and we have a 2-year plan for how we're going to maintain our competitive lead in this market.
What kind of data is it for the building? You said it's available data. What kind of data is it?
So we're starting from raw sensor data, so that's aerial and street level photographs, laser scans, and we do pull in traditional GIS data where relevant. We're working with data on a city scale, so we get data about an entire city and work with that all at once.
The video game sales is a really interesting one. Do you anticipate expanding that vertical?
Yes.
And how are you pricing and structuring that model?
Definitely. So our go-to-market strategy has been starting with early adopters in the AEC market, because we discovered relatively early in our company development that we could meet the needs of AEC customers with relatively low detail models, that even a plain white massing of a neighborhood was something that our architecture clients were spending a month hand building to their great pain and frustration. As we've gotten to higher and higher levels of detail, we found that we have what gaming and simulation customer needs, and we've been expanding into that vertical. We price that generally, actually very similarly to the architecture and engineering vertical, in that while a game is being developed, we charge that monthly or annual license, and then when they go out and redistribute our models as part of their software or their game, that's where we charge the royalty, so that their costs scale with the popularity and the success of their game, and our revenue scales as well. Good job.